Hello again, welcome to a new lesson. You have in front of your eyes the third big change in computing. We have seen two changes. 1. Git. 2. Cloud. But the two really start from this idea. Virtualization. What do we get with virtualization? Better optimization of resources. Resources can be local, resources can be remote. The moment we get to virtualize things, we can take advantage of them better. We are going to try to explain it. We start from traditional devices. A PC, an old server. It has its hardware, its Windows, its Linux, its Mac. Well, Linux would not be hardware, but good. Any Lenovo, Toshiba, Alienware. Its operating system and applications. And then someone says, well, I want to try to divide this to have at the same time this application. Windows, this one in Mac, this one in Linux. And the first step is a virtualized display. We continue with the operating system, and here again the operating system. Well, it was a first approach, but it is repeated. We have here a core function from Linux that occupied, let's suppose, 5 megabytes. Well, 5 megabytes, plus 5 megabytes, plus 5 megabytes. Let's say that this first approach did not use resources correctly. However, it has been used a lot. The most famous is VMware. So, let's say that this is evolving and another idea arises. We continue with the goal of trying to optimize resources. So, I have my 32 gigabytes of RAM and let's suppose 1 terabyte of hard disk, and I want to be able to run applications from different systems or different applications of a platform. For example, I want to run a MySQL, a database, and at the same time also an Oracle, a more powerful. A Java server. And I want everything to work. And I want to optimize my resources as much as possible. So, it goes around a bit, the situation is twisted a little more, and the idea of containers. So, what is a container? Well, I say this application that needs the A, B and C library. Well, only with A, B and C. This other one, the DEH. With the DEH. So, they are created as small applications with the essential. And not only with the essential, but it is like a temporal image. Not temporal with respect to what can be erased. Temporal with respect to what I have here. I am going to talk about my experience. The Drupal 5.02 that used PHP 5.02 and the libraries of 2004. And I have here an application of Node.js of 2017. And I have a later application of MongoDB of 2010. So, they have the specific libraries of that temporal moment. That is, they are not updated. If I had a specific version of a library, it is not updated. So, that is a bit the idea and the great improvements that it brings to the focus of containers. It is like an image of what is working, period. So, what is working is what is always going to run. and it will always work. So, what peculiarity does the operating system have? It is unique. We cannot have containers that work at the same time in Linux, in Mac, in Windows. We have containers, all that work in Linux. Containers, all that work in Mac. Containers, all that work in Windows. And it is a bit the idea. They are smaller applications that are based on a layer of execution of containers. And because of the size of the system, we are going to change the app. Let's see if we understand it a little more. I have gone faster. But hey, we had, as I have told you, these 3 applications. The active template is repeated. And we already moved on to this container format. So, virtualizers, there have been many. The 3 most famous are VMware, VirtualBox, and Hyper-V. Containers, the most famous is Docker, but it is not the only one. It is not the only one. There are more containers. There are more containers, engines to be able to adjust containers. So, we have already passed that instead of having applications with virtualization in our, we have small applications that are executed as containers. So, one of the challenges is to try to convert these large applications to these small. That is another different topic. We are talking about the focus of microservices and others. But I want you to understand the concepts. So, the main base is Docker, the most famous. But there is more. And we are going to make the situation a little more. These containers are very. Even Docker generates a system so that if we have this application that goes up a lot, it is a. We want it to always have 10 copies. So, we have Docker Swan, which is like a. Large hive that will always have 10 copies. If one falls, it creates it. And it is a bit what Docker provided us. So, Google sees what there is. Google has many applications, many containers running. And it sees that it is necessary to give a little more twist to the situation and create. Kubernetes. So, we go from containers to orchestrators. It creates Kubernetes. Google, of course, has its Kubernetes, which will be the repair, but at the same time it donates it. A smaller project to the public domain. Then Kubernetes enters the scene and everyone wants to use it because it is very good. So, how does Kubernetes improve the Docker structure that we had? Of course, we continue with our of containers. We continue with our idea of microservices, of small applications that we want to hide many. Well, the advantage that Kubernetes incorporates is that it allows you to better organize large of containers. So, you had an application of for services, the same with Swarm, you could manage it well. But if instead of being 4, there are 4,000 services, then it will be very, very difficult. So, we enter a new product based on Docker or some container registers, but at the same time it certain facilities to ensure the functionality that we want, but at the same time to allow us communication. So, the way Kubernetes works is that it has a system that does magic, although you already know. Magic does not exist, it is all architecture, so that it allows everyone to The nodes can be seen between them. This is called a database, this is called a web server, this is an application server, and they can be seen wherever they are, it does not matter where they are. Here is a system that says, I want to get to the database, and it says, well, you have to do it. This, and it goes to the database. So that's the first big advantage. The second big advantage is this one here, which allows you to connect with cloud providers. What does this mean? This one says, I want to get to the database, but it also says, I want to have an Oracle database. Here I do not have an Oracle, and it asks cloud, give me an Oracle database, and it already has an database in cloud. I want to have a balancer. What is a balancer? A balancer is really a product, an application that you to optimize the requests that a service has. For example, a balancer, if we want to go to the restaurant of Pepito Perez, and the restaurant of Perez, which is on Romero Street, is closed, the balancer tells you, hey, the one that is open is one on Princesa Street. So you know that instead of going to Romero Street, you have to go to Princesa Street. Well, it is same balancer idea that applies at the computer level in any type of product and architecture. So we have that Kubernetes is going to provide us with the same Docker philosophy, but improved. We continue to have small applications, but with more control. In other words, we are not only going to start from the idea of a container, but we are going to more powerful objects than managing containers. So, for you to know the names, I'm not going to explain it, because this is a Kubernetes course. We have replicas, we have deployments, we have services, we have ingress, and more. More, and more, and more. This is infinite, because as soon as we have a philosophy where we know that Drupal always has 10 nodes in Europe, 10 nodes in America, 10 nodes in Asia, and if a node falls, it knows that it to create another, because this approach allows us to create any infrastructure on the planet. And this is what Kubernetes allows. So, I hope it has been clear. I don't want to mess with OpenShift, which would be another twist. I hope it has been clear, and see you in the next lesson.